For most of your life, the moon has probably felt familiar. It rises. It changes shape. It hangs above the horizon like a silent companion that has watched every generation of human beings live and die beneath it. You have seen it so many times that it is easy to believe you understand it. A barren rock, a dead world, a beautiful object in the sky, a place we visited long ago and then somehow stopped visiting. But the deeper you look, the stranger the moon becomes. In 1969, NASA deliberately crashed a spacecraft into the lunar surface. The instruments left behind recorded something so unexpected that scientists reached for the strangest phrase they could find. They said the moon rang like a bell. Not for seconds, not for a minute, for nearly an hour. And when the experiment was repeated with a much larger impact, the vibrations lasted for more than 3 hours. Years later, on the far side of the moon, astronauts heard eerie sounds in their headsets while cut off from Earth. They debated whether they should report what they were hearing at all. For over 1,000 years, observers on Earth have described flashes, glows, and strange lights appearing on the lunar surface. Modern science has explained some of them, but not every report sits comfortably inside one neat category. Now we know there are real caves beneath the moon's surface, real underground voids, possible shelters, possible time capsules, possible gateways into a lunar world that no human being has ever entered. The moon may hold water ice. It may hold industrial value. It may hold the first practical shelter for a permanent human presence beyond Earth. And right now, after half a century of absence, human beings are on their way back. So tonight, we are going to the moon. Not the moon of children's books, not the moon of romantic poetry, not the simplified moon of classroom diagrams. The real moon. The one that vibrates strangely when struck. The one with a hidden face that once isolated astronauts in complete silence. The one with unexplained lights, confirmed caves, and a birth so violent that scientists still argue about how it happened. The one that helped make Earth habitable, and the one powerful nations are now racing to claim. Over the next 2 hours, we are going to follow its mysteries, its science, its myths, and its future. We will begin with the experiment that made the moon ring like a bell. We will listen to the music heard behind the far side. We will examine the lights that have been reported for centuries. We will confront the collision that may have created the moon itself. We will descend into the underground world hidden beneath its surface. We will separate scientific truth from the fantasy of the hollow moon. We will look at the secret mission that almost certainly never happened. And finally, we will ask the question that hangs over all of it. Why are we really going back? Because the truth is this. The moon is not becoming interesting again. It was always strange. We just stopped paying attention. When NASA hit the moon and it kept ringing. November 20th, 1969. The first moon landing was already history. Apollo 11 had changed the world. Human beings had walked on another world, planted instruments, collected samples, and returned home alive. Now Apollo 12 was ending. Astronauts Pete Conrad and Alan Bean had completed their work on the surface. Dick Gordon waited in the command module above. The lunar module ascent stage had already done the one thing it needed to do. Lift the moonwalkers back into orbit. Its job was over. So NASA decided to use it one last time. Instead of leaving the empty ascent stage drifting uselessly in lunar space, mission planners sent it back down. They aimed it toward a chosen impact point on the moon, not far from the seismic instruments the astronauts had set up. The goal was simple. Hit the moon with a known force. Watch what happens. Learn something about what lies below the surface. In principle, it was elegant. Controlled impact. Seismology. The same basic idea geologists use on Earth, but now performed on another world. And the ascent stage slammed into the moon at high speed. The impact energy was equivalent to a substantial explosive blast. The seismometers recorded the shock immediately. That part was expected. What happened next was not. The moon kept vibrating, not briefly, not like Earth. The signal rose, peaked, and then decayed with extraordinary reluctance. It went on for nearly an hour. That startled scientists because Earth does not behave like that. If you strike Earth hard enough, the ground moves, yes. But the energy is absorbed and scattered through a wet, fractured, geologically active planet. Water in rocks helps damp seismic waves. Molten or partially molten material helps dissipate them. Earth is dynamic, layered, and messy. Vibrations fade. The moon is not Earth. The moon is incredibly dry. Its crust is rigid. Its interior behaves very differently, and because of that, seismic energy can travel through it in ways that feel almost uncanny to us. NASA scientists tried to describe what they were seeing with a phrase vivid enough to communicate just how unusual it felt. They said the moon rang like a bell. That phrase would live much longer than they intended. Because once you tell the public that the moon rang like a bell, people start asking the most dramatic possible question. Does that mean the moon is hollow? Mainstream science says no. And not just no in a casual sense. No with real evidence behind it. Over time, the moon's internal structure has been studied through seismic data, gravity mapping, rotational measurements, and modeling. The moon has a crust, a mantle, and a small, dense core. It is not an empty shell. It is a real planetary body with internal layers, just different from Earth in critical ways. But the ringing did not end with Apollo 12. NASA ran the experiment again under even more dramatic conditions. After Apollo 13 suffered the service module explosion that nearly killed the crew, the mission never landed. But once the astronauts were safely on their way home, NASA still had an opportunity for science. The spent S-4B rocket stage, much more massive than the discarded lunar module ascent stage from Apollo 12, was directed into the moon. This impact was far larger, and the response was even stranger. The moon vibrated for over 3 hours. 3 hours. That is not because the moon is hollow. It is because the moon is dry, rigid, and unlike Earth in the exact ways that matter most for seismic behavior. On Earth, energy gets soaked up. On the moon, it keeps moving. Still, the phrase stayed. It escaped the laboratory. It escaped the technical papers, and it entered popular culture, where it remains one of the most famous things NASA scientists ever said about the moon. The scientific explanation is strong, but what matters for our story is this. The ringing experiment taught us something fundamental. The moon may look familiar from Earth, but when you physically interact with it, it behaves in ways that feel alien. And the ringing was only the first of many such moments. Because months before those impacts, another Apollo crew had an experience on the far side of the moon that would become one of the strangest stories ever attached to human spaceflight. The sounds behind the moon. May 1969. Apollo 10 was the full rehearsal before Apollo 11. Everything that needed to work for the first landing had to be tested. The command module would orbit. The lunar module would separate, descend close to the surface, then return. No landing, no first step. Just proof that the hardware and the procedures were ready. The crew was extraordinary. Thomas Stafford, John Young, Gene Cernan. These were not casual observers. They were among the most highly trained pilots and astronauts on Earth. And during part of the mission, the spacecraft operated on the far side of the moon. That matters because the far side is not only visually hidden from Earth, it also blocks direct radio communication. When astronauts pass behind the moon, Earth disappears in one of the most literal and unsettling ways possible. No live voice from mission control, no immediate contact, no one listening in real time. For a while, the crew is simply gone from Earth's reach. That was true for Apollo 10. And in that isolation, the astronauts heard something. On the recorded mission tapes, the crew can be heard discussing an eerie whistling or musical sound coming through their headsets. One of them remarks that it sounds like outer space music. Another wonders who would believe them if they reported it. That line is what made the incident famous. Because the astronauts did not respond like men hearing some familiar, harmless static. They responded like men encountering something strange in an environment where everything already felt psychologically amplified. The far side of the moon is unlike anything human beings know naturally. No atmosphere, no outside sound, no Earth in view, no contact with home. Only instruments, systems, and the blackness outside. In that environment, even minor anomalies change character. A strange sound no longer feels trivial. It feels charged. Now, scientifically, the most likely explanation is strong and fairly ordinary. The sound was almost certainly radio interference, beat frequencies produced by interaction between the VHF systems in the command module and lunar module. Radio systems can produce eerie oscillating tones when signals interact in the right way. It is a well-understood phenomenon. Later, astronauts heard similar sounds. Michael Collins, orbiting alone during Apollo 11, knew about the possibility and described how disturbing it would have felt if he had not been warned. That detail matters enormously. Expectation shapes fear. If someone tells you in advance, you may hear an odd musical whistling because of radio interaction, then the sound becomes a technical curiosity. If nobody tells you, and you hear it while alone behind the moon, it becomes something else. That is the real significance of the Apollo 10 incident. Not that it proves something supernatural. It proves how the moon changes the emotional weight of ordinary events. The far side is a place where technical glitches can feel like haunting. That is part of what makes lunar flight psychologically different from ordinary orbital spaceflight. The moon is close enough to feel reachable and far enough to feel mythic. The astronauts are not only farther from Earth, they are farther from context. Familiar things lose their usual emotional shape. The radio sound almost certainly had a mundane cause, but the fear it generated was real. And that matters because the moon has repeatedly shown the same pattern. Ordinary physics, extraordinary feeling. The next mystery continues that pattern perfectly. For centuries, people have watched the moon's surface and seen lights. Some of those lights now have solid explanations. Others still leave just enough uncertainty to keep the old fascination alive. The lights that kept appearing. The moon looks stable. That is one reason the reports of flashes and glows have always unsettled observers. The moon is supposed to be steady, silent, and unchanged. When something briefly lights up on its surface, the contrast between expectation and event is powerful. Reports go back centuries. One famous medieval account describes monks watching the crescent moon and seeing what appeared to be a fiery outburst from one horn of the crescent. Later, astronomers would record their own anomalies. Some described brief flashes. Others saw localized brightenings. Some reported reddish colorations or hazy effects that seemed to obscure detail in certain craters. Over time, these reports accumulated into a category now known as transient lunar phenomena. That phrase is important because it does not assume one explanation. It simply describes short-lived visual changes observed on the moon. And science has now demonstrated that at least some such events are absolutely real. The moon is constantly hit by meteoroids. With no atmosphere to slow them, even tiny objects slam directly into the surface at tremendous speeds. When they do, they can produce brief flashes of light visible from Earth through sufficiently sensitive instruments. Modern monitoring projects have recorded many such flashes directly. So one class of lunar light events is no longer mysterious. They are impacts. Another class may involve gas escaping from the moon's interior. The moon is often described as geologically dead, but that description hides nuance. Certain gases, including radon, can seep through fractures and weak zones. In some locations, such activity may contribute to visual changes or localized glows. Crater Aristarchus is especially important in this context. It has long been associated with unusual reports and also with evidence suggesting elevated gas-related activity. That does not make Aristarchus supernatural. It makes it scientifically interesting. Still, not every old report fits easily into one neat category. Some events seem too long-lasting, some too dramatic. Some may simply reflect observer bias or imperfect historical reporting. Humans tend to watch dramatic features more closely than bland ones. Over centuries, certain famous craters accumulate more reported anomalies simply because more eyes keep returning to them. So where does that leave us? With something more interesting than either total mystery or total dismissal. The moon is active enough to produce real short-lived optical events. Science has explained some of them well. Other reports remain more ambiguous, especially older ones. And the existence of real impact flashes and real outgassing means the moon is not the perfectly inert body older textbooks often implied. That matters because every time science explains one of these events, the moon becomes less dead and more dynamic. It also teaches us something else. The moon does not need aliens or fantasy to be strange. Reality is strange enough. And the deeper you go, the stranger it becomes. Because if lights can flicker on the moon now, what does that say about the moon's deeper history? What kind of world produces those flashes, those gas releases, those impacts, those seismic responses? To answer that, we have to go back to the beginning. The collision that may have created the moon. The most widely accepted theory for the moon's origin begins with violence. Not small violence. Not the kind of violence human imagination handles easily. Planetary violence. In the early solar system, worlds were still forming. And collisions were part of that process. Large bodies crossed unstable paths. Some merged. Some shattered. Some were transformed beyond recognition. The giant impact hypothesis proposes that a young Earth collided with a Mars-sized protoplanet, often called Theia. The collision was so intense that huge amounts of material were blasted into orbit around Earth. Over time, that material gathered together and became the moon. This theory is powerful because it explains many major lunar facts. Why the moon is so large relative to Earth. Why it has a small iron core. Why the Earth-Moon system has its current dynamics. Why the moon lacks some volatile materials it might otherwise be expected to hold. For a while, it looked like the elegant answer. Then the rocks complicated the story. Apollo brought samples home. When scientists analyzed isotopes in those rocks, they discovered that the moon looked too much like Earth. Oxygen isotopes, especially, were uncomfortably similar. That created a problem. If most of the moon's material came from a foreign impactor mixed with some Earth material, why does the moon look chemically so much like Earth and not more like a blend? This is one of the great unresolved puzzles in lunar science. There are possible answers. Maybe Theia formed in nearly the same part of the solar system as Earth and shared similar chemistry. Maybe the impact mixed the materials more completely than earlier models assumed. Maybe the collision created an extreme vaporized structure, sometimes called a synestia, from which both Earth and Moon condensed in a much more intimate chemical relationship. Maybe multiple large impacts over time contributed instead of one single clean event. All of these ideas are being studied seriously. What matters for us is this. The moon's origin is not a solved fairy tale. It is an active scientific problem. And that is important because it changes how we see the moon. The moon is not only nearby, it is also one of the solar system's deepest unsolved archives. Its very existence carries evidence from a time when worlds were being made and broken. And then, after all of that violence, it ended up in a relationship with Earth so oddly perfect that another mystery appears. The eclipse coincidence. The Sun is about 400 times wider than the Moon. It is also about 400 times farther away. Those two facts combine to produce one of the most astonishing visible coincidences in the solar system. The Sun and Moon appear almost exactly the same size in Earth's sky. That is why total solar eclipses are possible. The Moon slides in front of the Sun and covers it almost perfectly, revealing the solar corona. This is not only beautiful, it has mattered historically. Eclipses shaped myths, calendars, religious interpretations, early astronomy, and later scientific breakthroughs. The visible corona during total eclipses became a rare natural laboratory long before the space age. And the strangest part is that this is temporary. The Moon is slowly receding from Earth. Over immense spans of time, that changes the geometry. In the past, the Moon appeared larger. In the future, it will appear smaller. We happen to live during the era when total eclipses of this kind are possible. No design is required to recognize how extraordinary that is. It is enough that it is true. The Moon also keeps one face turned toward us at all times. Tidal locking explains this well. Again, the science is solid. Again, the result remains emotionally uncanny. The Moon is full of features that are scientifically understood and still feel uncanny anyway. That is part of why it keeps generating myths. But some of its most important secrets are not about its face in the sky at all. They are underground. The caves beneath the Moon. For years, scientists suspected that lava tubes and caves might exist under the lunar surface. Volcanic terrain on Earth offers a clear precedent. Lava can flow under a hardened surface crust, then drain away, leaving tunnels behind. On the Moon, lower gravity means such structures could be larger and remain stable longer. Orbital images showed pits that looked promising, dark openings that may have been skylights into underground spaces. Still, suspicion is one thing, confirmation is another. Then, with improved radar analysis and orbital data, scientists finally confirmed that at least one such pit opens into a real underground cavity. That changed everything. A confirmed lunar cave is not just an interesting footnote. It is a strategic revelation. The Moon's surface is brutal. During the lunar day, temperatures soar. During the lunar night, they crash. Radiation strikes unprotected terrain continuously. Micrometeorites hit without atmospheric shielding. Lunar dust is abrasive and reactive. Building a sustainable habitat on the open surface means solving all of those problems at once. A cave offers a natural solution to many of them. Stable temperatures, radiation protection, micrometeorite protection, a sheltered volume already present. That makes caves one of the most promising environments for a future lunar base. But their importance goes beyond shelter. Caves also preserve history. The surface of the Moon is constantly altered by impacts and exposure. Underground, ancient geological layers may survive in much cleaner form. A lunar cave could preserve records of the Moon's volcanic history, its structural evolution, and possibly trapped volatiles such as water ice. In other words, the caves are not only shelters, they are archives. And they are the sort of archives that human beings are likely to enter within the next decades. The Moon is no longer just a place we land on briefly and leave. It is becoming a place we may inhabit below the surface. That shift changes the whole meaning of lunar exploration. Why the hollow moon story wouldn't die. When people hear that the Moon rang like a bell, has unusual density compared with Earth, contains strange underground voids, and holds unresolved mysteries about magnetism and formation, some of them start stitching these things together into one dramatic explanation. That is how the hollow moon story survives. It takes real anomalies or striking facts and packages them into a single answer. Maybe the moon is artificial. Maybe it is hollow. Maybe it was placed here. Modern science does not support any of that. The moon's internal structure, measured through seismic data, gravity studies, and rotational behavior, is not that of an empty spacecraft shell. It is a layered rocky body. The ringing has a real seismic explanation. The shallow crater claims have geological explanations. The density difference has formation-based explanations. The titanium in lunar material is natural mineral content, not artificial hull plating. The theory fails scientifically, but it succeeds psychologically for one reason. It tells one story instead of many. Science is often unsatisfying to the dramatic imagination because it says, this effect has one cause, that effect has another. This feature is partly understood. That one remains open. Conspiracy thinking wants a master answer. The moon resists that. Its mysteries are real. Its dramatic, one-size-fits-all explanation is not. Still, the fact that the moon inspires such theories tells us something important. People feel, correctly, that the moon is more unusual than the casual version of it suggests. The mistake is not sensing that strangeness. The mistake is rushing toward the wrong explanation. The secret Apollo mission. That wasn't Apollo ended abruptly enough to leave emotional scars. Missions 18, 19, and 20 were once part of the plan. Then they vanished. Budgets tightened. Public interest faded. The political will that had carried Apollo began to collapse. That sudden ending created fertile ground for stories about hidden continuations. One of the most famous was the fake story of a secret Apollo 20 mission, supposedly launched in partnership with the Soviet Union to investigate a strange object on the far side of the moon. The story had everything needed for survival. Missing missions, Cold War secrecy, the far side of the moon, a mysterious object, buried footage, alien implications. It was almost certainly a hoax. There is no credible evidence a Saturn V class mission launched secretly that way. No launch could have been hidden on that scale. No reliable records support the claim. The footage associated with the story appears fabricated or repurposed. And yet the story endured, because it fed on something real. The sense that Apollo ended too suddenly. The sense that something this extraordinary should not have simply stopped. That feeling is emotionally understandable. Humans walked on the moon. Then they did not. For generations. It feels wrong in a narrative sense, even if the political explanation is straightforward. That is why false stories rush in. They offer continuity where history offered silence. But the real reason we are going back now is not because hidden missions never stopped. It is because the moon has become valuable again in an openly strategic way. The real reason. The moon matters again. Exploration is part of the public language around the moon. Science is part of it too. But beneath both lies something older and harder: resources and power. The lunar South Pole is the most important region in this new race. Why? Because permanently shadowed craters may contain water ice. Water on the moon changes everything: drinking water, oxygen, hydrogen, fuel, life support, industrial value. A moon with usable water is not just a place to visit. It is a logistical platform. Then there is helium-3, an isotope often discussed in connection with future energy systems and other advanced applications. Some public claims about helium-3 drift into speculation, especially around fusion. But the broader point still stands. The moon contains material that governments and private companies now treat as economically and strategically meaningful. And once that becomes true, The moon changes category again. Not myth, not dead rock, not only science, infrastructure, territory, competition. The United States knows this. China knows this. Commercial actors know this. This is why the moon feels urgent now in a way it did not for decades. It is not just that we remembered how beautiful it is. It is that we remembered how useful it may become. That does not erase wonder. It does not erase science. It does tell us why the money and urgency suddenly returned. Human beings are returning now. After more than 50 years, humans are again traveling toward lunar distance. That fact is not symbolic alone. It is operational. The modern return to the moon begins not with fantasy, but with systems. Rockets, capsules, missions, timelines, crews, instruments, and the renewed willingness to go. The current generation of lunar missions is not only about repeating Apollo, it is about beginning something different. Longer presence, different landing regions, better instruments, possible base construction, possible use of caves, possible resource extraction, a future in which the moon becomes a stepping stone, a laboratory, and maybe eventually a permanent outpost. That future is not guaranteed, but it is closer now than it has been in decades. And that changes everything. Because once humans are actively returning, the moon stops being a closed historical chapter. It becomes an unfinished one. What Apollo brought back. Apollo returned more than flags and stories. It returned samples. Those samples transformed lunar science. They showed the moon once had a molten surface ocean. They showed the moon's geology was more complicated than assumed. They revealed evidence of water trapped in ancient materials. They revealed magnetized rocks, evidence that the moon once had a magnetic field of real significance. And then there was the dust. The astronauts repeatedly commented on its strange smell once brought into the cabin, like spent gunpowder. That was not mysticism, it was chemistry. The lunar surface is an extreme environment. Dust grains remain sharp, reactive, and unlike weathered Earth material. That dust became one of the great practical warnings Apollo gave future explorers. The moon is not only scientifically rich, it is materially hostile. Living there will not be easy. But the samples also proved something more inspiring. The moon is not simple. Every rock brought back told a larger story than expected. The moon and Earth are bound together. The moon drives Earth's tides. It stabilizes our planet's axial tilt. It helps shape the environmental conditions under which complex life evolved. Without the moon, Earth would still be a planet. But it might not be the planet we know. That gives the moon a special status in human thought. It is not just another world. It is another world that helped make this world possible. That alone would be enough to justify our fascination. But fascination becomes something deeper when human beings go there and come back changed. The astronauts who came back. Different. Apollo astronauts did not all respond the same way to the moon. Some became more reflective. Some became spiritually transformed. Some struggled emotionally after returning. Some described the experience as impossible to fully communicate. That is understandable. Seeing Earth from the moon changes scale. It changes meaning. It changes the relationship between self and planet. The overview effect is the phrase often used now, but the phrase feels almost too clinical. In reality, it seems to be something closer to a fracture in the ordinary frame of thought. Earth becomes small. Borders become absurd. Atmosphere becomes visibly fragile. Home becomes both everything and something you could almost cover with your thumb. No one experiences that and returns unchanged. That was true in Apollo. It will be true again now. The moon is not only a scientific destination, it is a psychological force. What are we really looking for? So what is the moon really? A dead rock? No. A supernatural object? No. A solved world? Also no. The moon is a place where real science keeps finding real surprises. A place that shakes in strange ways. A place with a hidden face that amplifies isolation. A place where flashes still appear. A place with confirmed caves and unresolved magnetic history. A place born in violence and still not fully explained. A place that helped shape Earth's habitability. A place that powerful nations now want to use, inhabit, and possibly compete over. And perhaps, above all, it is a mirror. For science, for ambition, for myth, for fear, for wonder. The moon does not need false mysteries to be compelling. It is already compelling. And that may be the final lesson. We are not going back because the moon has become less mysterious. We are going back because it remains too important, too useful, too scientifically rich, and too psychologically powerful to ignore. The moon still asks the same thing it has always asked. Look closer. And the more closely we look, the clearer one truth becomes. The moon is not just a light in the sky. It is a world that still has the power to unsettle us, shape us, and call us back.